24 paper number 12. Let's take a look at the first question. The sequence UN, U1, U2, U3 is given such that the U1 is equal to 4 and the UN plus 1 equal to the 3UN minus 2 for n greater or equal to 1. Prove by induction that this statement is true for all positive integers n. So at first, we just need to let our n start from 1. Okay, we just say that when n equal to 1. So when n equal to 1, you just change this n here become 1 is equal to 4 and is matched with this answer. So we just say that it's true for n equal to 1. Now we assume that is true for n equal to k. That means the UK, this statement over here, change n become k, uk is equal to 3 power k plus 1 for all positive integers. Then now we want to make our n equal to k plus 1. So when n equal to k plus 1, based on the definitions over here, uk plus 1 is actually 3uk minus 2. And because we already have the uk, just replace it inside. Then you get this one as the 3 multiplied by 3k plus 1 minus 2. And you're able to show that it's a 3k plus 1 plus 1. So you can see that is a true for n equal to k plus 1 as well. Okay. So therefore, conclusion, by the PMI, principle of mathematics induction, okay, so we know that the un is equal to the 3 power n plus 1 for all positive integers n. Okay, such that u1 is equal to 4 and un plus 1 equal to the 3 un minus 2 for the n greater or equal to 1. So this will be the conclusion answer for the question number 1. Done. So now we move on to the question number 2. As given here, and the plane pi contain L1 and is parallel to the vector of 2i plus 5j minus 4k. Find the equations of pi giving your answer in the Cartesian form. So what you need to do is, at first we need to write L1. Usually I will write them in a matrix form. Okay, so you can see that the question mentioned that this plane pi is contain L1 and is parallel. Okay, this is parallel to the 2i plus 5j minus 4k. So we need to do the cross product in order to get the normal vector. Okay, so over here to find the normal vector, we just take the cross product between the directional vector 1, negative 1, negative 4 and the parallel vector over here 2i 5j minus 4k. So if we do the cross product, we'll get this one as a 24i minus the 4j plus the 7k. That will be my normal vector of the plane pi. Okay. So since you have found the normal vector of a plane pi, so therefore you can find the equations of pi. So this is the x, y, z. This is the normal vector, 24, -4, and 7. 24, -4, and 7. And we will, because the plane pi contain the line 1, so the line 1, I will use the position vector of line 1 here. So you get 24x minus the 4y plus the 7z is equal to the 24 minus 12 minus 7. You get the answer 5. So therefore, your equations of the plane pi will be 24x minus the 4y plus the 7z is equal to 5. So that is the answer for the number 7, number 2a, number 2a. So now we move on for the number 2b. Now we have a line number 2 is parallel to this vector 5i minus 5j minus 2k. We want to find the acute angle between the line number 2 and the plane pi. So we have a plane pi over here, right? And let's say the line number 2 go like this. So we have the normal vector for the plane is n. So if you do the dot product, you will get the angle theta over here. But the angle between the line and the plane is actually 90 degree minus theta. Okay. Or maybe we can say that the angle over here is theta, and this one will be 90 degree minus the theta. We can do like that. So over here, if we use this concept to find this angle, we just need to do the dot product. Okay, just take the dot product between the line number 2 and the normal vector. The normal vector just now was 24, -4, 7. 24, -4, 7. So if you find the magnitude, you will get 576 plus 16 plus 49. And the directional vector for the line number 2 is 5, -5, -2. This will be 25 plus 25 plus 4. Then the cos 90 degree minus theta, it will become sine theta. To find acute angle, we put modulus. So this one will be modulus of 120 plus 20 minus the 14 divided by square root of 641, square root of 54. Therefore, just press the calculator and you can get the answer for the acute angle between the line number 2 and the plane pi. So the answer will be 42.6 degree. This will be the answer for number 2b. And moving on, we have question number 3. Giving you the 3 equations over here: alpha, beta plus gamma plus delta equal to 2. Alpha square plus beta square plus gamma square plus delta square is a 4. And alpha cube plus beta cube plus delta cube, gamma cube plus delta cube is a 4. Okay, so this is the information given. Okay, so the question over here, the first part is that they want you to find the product of the 3 roots over here. Okay, so over here for this question, we will use this result: alpha square plus beta square plus gamma square plus delta square is actually alpha plus beta plus gamma plus delta square minus the 2 of this. Okay, so this is what we want to find. What you need to do now is just to put 3 here, 2 here, minus this. So therefore, your answer alpha, beta plus alpha gamma plus alpha delta plus beta gamma beta delta plus gamma delta is equals to the 4 minus 3 over 2 equal to half. That will be the answer for the part A. Done. And for the part B, over here, the equation looks very long, but if you look at them carefully, this is a group number 1, this is a group number 2, this is a group number 3, and this is a group number 4. We separate them into 4 different groups. Okay, so a bit long for me to write everything down, so I think I will just straight away factorize the group number 1. If I factorize it, I get this. The group number 2, if I factorize this one out, I get this. The group number 3, if I factorize the gamma square out, I get this. Same thing happened for the group number 4. I factorize the delta square out, I get this. Okay, so now what I need to do is that I need to make it a trick, because this one I can make it become we know that alpha plus beta plus gamma plus delta is equals to 2. Okay, we know it's equal to 2. So that means beta plus gamma plus delta is actually equal to 2 minus alpha. Okay, so I can make this become 2 minus alpha. Similarly, I will make this become 2 minus the beta. I will make this become 2 minus gamma. This one I can make it become 2 minus the delta. Okay, so we are applying this result and this concept, and we can get this result. And if you expand, you will get 2 alpha square plus beta square plus gamma square plus delta square minus the alpha cube plus beta cube plus gamma cube plus delta cube. So from the result that we have, this is a 3 and this is a 4. 6 minus 4 is a 2. Done. That will be the answer for the part B. And now when moving on, C. C, they are giving you that this alpha, beta, gamma, delta fulfill these equations. They are the roots of these equations. Now we want to find alpha power 4, beta power 4, gamma power 4, and delta power 4. So for me, usually I will just let Sn equal to alpha power n plus beta power n plus gamma power n plus delta power n. Okay, so we just make 6x power 4 equal to 12x power 3 minus a 3x squared plus 2x minus a 6. Oh, this is a minus. So that means 6s4 is equals to 12s3 minus a 3s squared minus a 2s1 minus a 6s0. So I already have s3. From here, from the result here, this is s1. This is the s2. This is the s3. Okay, so s1, s2, s3. Yeah. So s3 is 4. S2 is 3. S1 is 2. S0 is 4. So over here, just use your calculator. S4 is equal to the 48 minus a 9 minus a 4 minus a 24 divided by 6. Press the calculator, you will get the answer as 11 over 6. Done. So this will be the answer for the question number C, part 1. And now moving on, we have C part 2. Now we want to find S5. This is S5. So to find S5, all I need to do is I take this equation, I call this one equation 1. I take the equation 1 multiplied by x, I get 6x power 5 equals to the 12x power 4 minus the 3x power 3 minus a 2x squared minus a 6x. Then therefore I have 6x5 equals to the 12s4 minus a 3s3 minus a 2s2 minus a 6s1. So just replace the value. Just now this one is 11 over 6. This one is 4. This one is a 3. This one is a 2. So your S5 is equals to the 22 minus 12 minus 6 minus 12 divided by 6. So this one is the negative 8 over 6. It will be negative 4 over 3. Done. That will be the answer for the question number C, part 3. That will be the answer for the question number 3. And now we move on to question number 4. Given as following here, they want you to show that the product of the CAB is equals to the matrix given here. So what you need to do, just very straightforward questions. Just write C multiply A and then multiply B. Then in order to multiply, we can choose to multiply CA first and then multiply by B later. So to multiply CA, just need to multiply carefully. You will get negative 1, 12, negative 3, 9, negative 4, 21, and 0, negative 1, 0, negative 2, 3, 0. Now you multiply these two again, and you will get the answer as 3, negative 9, negative 7, 3, shown. That is the answer for part A. Now we move on. Part B. Find the equations of the invariant line through the origin of the transformations in the line y equals to the in the xy plane represented by the CAB. So to find the invariant lines, we just let the invariant line is y equals mx. Okay, so if you transform this matrix xy, then it will become xy. So your image will be at this. So that means this one, it will be 3, negative 9, negative 7, 3, x, mx is equals to the x, mx. Expand, you will get 3x minus a 7mx is equal to x. Then the negative 9x minus a 3mx is equal to the mx. Equation 1, equation 2. Take the 1 divided by 2, you get 3 minus 7m over the negative 9 minus 3m. Oh, this is a plus. Is equal to 1 over m. You can have something like that. Then just do the cross multiplication. 3m minus a 7m squared equals to the negative 9 plus 3m. 3m cancel. Therefore, your m is plus minus 3 over 7. You can write it as a 3 7 over 7. So therefore, your invariant line have two. One is y equals to the positive 3 7 over 7x. Another one is negative 3 7 over 7x. Done. That will be the answer for the part B. Now we're moving on to the C. C, they give you the matrix M like this, and they want us to describe the detail of this transformation. So this transformation is actually a stretch parallel to x-axis, stretch parallel to x-axis, with the scale factor. This is the scale factor of 3. Okay, the scale factor 3. Just mention scale factor 3 will do with the scale factor 3. That will be the answer for the number 4C. Move on. Find the matrix N such that the NM is equal to CAB. They're giving you this. So to find the N, the M need to go to the other side, or actually we don't really bring the M go to the other side. We actually just multiply M inverse here. Just actually multiply the CAB with the M inverse, and you get N. So in order to find N, we need to find the M inverse. M inverse is 1 over 3 of 1300. It will be 1 over 3001. So CAB and M inverse. CAB just now was 3 negative 7 negative 9 3. 3 negative 7 negative 9 3. Just multiply it. You get 1. You get negative 7. You get negative 3. You get 3. So this will be the answer for the number 4D. Moving on, we have question number 5. Sn defined as such where the UR is equal to x power FR minus the x power FR plus 1, where the x is positive. So they want you to find Sn. So that means that Sn is equal to this. UR, but the UR is mentioned like this. We just write down only. It will be x power FR minus the x power FR plus 1. So you just need to list out. It will be x F1 minus the x F2 plus the x F2 minus the x F3. This is the case where the R equal to 1. This is the case where the R equal to 2. And we want to put R equal to 3 until R equal to n. This is what we're planning to do. But however, this one don't need to write down. I will erase this. So you just understand what I am planning to do will do. So this one, it will be xf3 minus x. Dot, dot, dot until you plus with the x f power fn minus 1 minus the x power f of n plus until here. So you can see the pattern that they can cancel in such a way that at the end, this will equal to the x f1 minus the x power fn plus 1. That will be the answer for the part A. So now we move on to the part B. Now they're giving you FR is like this. They want you to find the sum. This one is to infinity. to infinity. So now the questions over here, your u r right now will be written as x power ln r minus the x power of ln fr is ln r. Okay, so it's ln r plus 1. Okay, so now the u1 plus u2 plus u3 plus a dot 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 is actually means sum to infinity of ur. You just need to replace the ur with just need to put it like this, make it become the limit of n goes to infinity, the sum of this one. And from the result of part A, we have found that is x power f1 minus x power fn plus 1. So it will be limit of n goes to infinity of x power ln 1 minus x power of ln of r plus 1. N plus 1, sorry. This is what we are having. Then this is it will be limit of n goes to infinity of 1 minus the x power ln n plus 1. Okay, so this will be the limit of infinity, sum to infinity. Okay, so for the series to converge, the value of x here must be between 0 and 1. Okay, so over here, we need to take away the equal sign because of your x is greater than 0, stated over here. So this is the answer. Okay, they want us to find the set of value x for which the series is converged. Oh, we need to find the sum to infinity as well. Okay, so to find the sum to infinity, that now we will need to be careful. Okay, so I need more space. Maybe I write it over here. Okay, so when the x is between 0 and 1, the sum to infinity over here, because this value is between 0 and 1, if you power of infinity, it will become 1 minus the 0 is equal to. Then when the x is equal to 1, now we want to consider the case where they are equal to 1. So when x equal to 1, sum to infinity, it will be 1 minus 1. That will be a 0. Okay, so this will be the answer for the question number 5B. Okay, now we move on. Now we question C, they say that FR right now is equal to the 2 log R base X. Okay, so 2 log R base X, that means your UR will be the X power 2 log R base X minus the X of 2 log R plus 1 base X. So we can make this become X log base X R square minus X R plus 1 square, and we will having R square minus R plus 1 square. Okay. So now the Sn, actually we do not need to do like this, but we can still simplify further. We can make this become negative 2r minus 1. Negative 2r minus 1. So the Sn, it will be equal to this. So it will be equal to this. Negative 2r minus 1. It will be equals to the negative 2 and n plus 1 over 2 minus the n. Simplify it, you will get negative n squared minus n minus n. It will be n squared minus a 2n. Minus n squared minus 2n. But the question, be careful. Be careful. They are looking for sum of Sn. So the sum of Sn is actually the sum of this. Like this. So according to the formula booklet FM19, this one will be negative n plus 1, 2n plus 1 over 6 minus a 2 n plus 1 over 2. Cancel this. Factorize the negative n plus 1 over 6 out. And inside here, you will get 2n plus 1 plus 6. Therefore, you get the answer like this. And that will be the answer for the question number 5C. A bit tricky, to be very careful. So now we move on to question number 6. S squared plus 3 over the S squared plus 1. Show that the C has no vertical asymptote and state the equations of the horizontal asymptote. So to find the vertical asymptote, we just need to let our denominator equal to 0. But it cannot equal to 0. Okay, that means you just say that this equal to 0 has no real solution. So therefore, no vertical asymptote. Okay, shown. Then for the HA, is actually y equal to the limit of x approaching to infinity of x squared plus 3 over the x squared plus 1 is equal to 1. That will be your horizontal asymptote. And then to show the range of the y is between 1 and 3, including 3 but not including 1. So what you need to do is just multiply your numerator, go to the other side, expand it, you will get y minus 1 x squared plus y minus 3. In order to have solutions, your b squared minus the 4ac must be greater or equal to 0. So if you simplify them, you will get this. So your y is between 3 and 1. Because of when the y is equal to 1, 1 is equal to x squared plus 1 over x. Okay, this is a 3. This one have no solution. Therefore, your domain of y is only between 1 and 3, not including 1, but including 3. Okay. Then now we want to find the stationary point. So to find the stationary point, we usually just need to do the differentiations. Keep the bottom, differentiate the top, minus keep the top, differentiate the bottom, divided, keep the bottom, differentiate the top, minus keep the top, differentiate. divided by the bottom square. Expand simplify, you will get this as a negative 4x. Your dy dx equal to 0, which means that your x is a 0. That will give you y equals to 1 over 3. So therefore, your stationary point have only one. Hey, sorry, I make a mistake. It's not 1 over 3. It's a 3. Stationary point is 0, 3. That will be your answer for the part C. Now we want to put all the information together to sketch a graph. So to sketch a graph, I draw freehand. So in exam, don't draw freehand. Use a ruler with proper scale to draw it. So this is the horizontal asymptote. This is the 1, and this is the 3. So your graph, this is obviously your graph is only within here. Okay. So and then you have a stationary point at 3. So obviously this must be maximum point. So your graph must be like this. So your graph must go like this, reach the maximum, and then go down. So this will be the graph for the D. Now remember, don't draw a freehand. Draw using proper scale. Okay. Then E. E, you have to be careful because this graph is y equal to the s squared plus 3 over s squared plus 1. So this one is actually reverse. Is actually 1 over fx. Okay, so I have to be careful. So over here we let fx is equals to s squared plus 3 over s squared plus 1. Therefore, the y right now is 1 over fx. So if this is 1 over fx, then what do you need to do? The stationary point over here will change from 0, 3 to become 0, 1 over 3. Okay. Then over here, your horizontal asymptote, it will be y equals to 1. Still y equals to 1. Okay, so now the graph will be like this. This is the 1. Your minimum point is 1 over 3 here. Then your graph will going to become like this. Okay, so this is the graph. Now they want you to draw, to find the inequality. Okay, so over here, you just need to let them equal. Two x squared plus 2 equal to x squared plus 3. X squared is equal to 1. Your x is equal to plus minus 1. That means when you draw the line, half over here, you draw the line half over here, you will have the intersection here is at 1, and the intersection here will be negative 1. Okay, so from the graph, in order for this, just say that from the graph, the solution for this inequality, it will give you your x is only between these two values. Okay, so the question didn't require you to draw this line, so there's no need for you to write the line on the diagram. But you should know that when it's a half, the graph will pass through this line. Okay, so this will be the answer for the question number E. So now we move on. Question number 7. Equations R equal to A cos theta plus sin theta for negative pi over 4 to 3 pi over 4, where A is a positive constant. Part A, find the Cartesian equations of C1 and show that it represents a circle, stating its radius and the Cartesian coordinates of the center. So for these questions, in order to convert the polar equations to Cartesian equations, all we need to do is just to multiply R for both sides. So if you multiply R for both sides, you will get R squared equal to the A R cos theta plus R sin theta. And we know that x squared plus y squared is a R squared. And we also know that R cos theta is a X, R sin theta is a Y. So therefore you have this. Complete the square. For X, complete the square for Y. And you get these equations of circle. Then this one will be 1 over 2A square. Okay, so therefore, this is a circle with the center at A and half A. The radius R is equal to the 1 over 2A, 1 over 2A. This will be the answer for the 7A. B, they want you to sketch the C1, stated the greater distance of the point C from the pole. Again, I draw freehand, but in exam, don't draw freehand. In exam, you need to draw with a proper scale. So this is the theta equal to 0. This is the theta equal to the pi over 2. Your center, half of the A here, half of the A is here. And the distance from here to here is exactly 1 over A. If you use Pythagoras theorem, then use Pythagoras theorem, then you can find that the distance here is exactly 1 over A. That means this is the radius. This is the radius. That means your circle will pass through this point. Your circle will pass through the pole. Okay, so you just need to use a protractor to draw it carefully. Make sure your circle pass through the pole. Will do. Okay, so this will be the circle. Then after that, I have to remind you again, I draw using freehand, so I didn't draw the circle nicely. In exam, you should draw it with proper scale and proper tools. Need to use protractor to draw it. Okay, so over here, how to find the greater distance? The greater distance is over here. This is the greater distance. So you can see that the greater distance is actually the diameter of the circle. So your R max. What is the diameter? The radius is 1 over 2A. So the diameter will be 2 over sec 2a. 2 over sec 2a is actually sec 2a. That will be a greatest distance. Okay, so this will be the answer for the number 7b. Now we move on. The curve C2 with the polar equations r equal to a theta intersects C1 at the pole and the point of the polar coordinates a phi and phi. Show that the phi is between 1.25 and 1.26. So over here, you should know that this one is a spiral. So if you try to draw a circle here, and this is the center, the spiral go like this. Okay. Spiral of a theta. The spiral of a theta go like this. Okay. So over here, we just need to have an idea. We just need to have an idea how the graph look like. So maybe we can just draw it like this. So this is the intersection point. This is another intersection point. So this intersection point is a phi and phi. Okay. So what you need to do now is, of course, our C1 is R equal to the A cos theta plus psi theta. Equation number 1. R equal to the A theta. That is equation number 2. Let them equal. Then you are having A cos theta plus psi theta is equal to the A theta. Cancel the A. And you can have cos theta plus psi theta minus theta is equal to 0. And I will let this whole expressions over here call f theta. Okay. I let this one call f theta. What I need to do is to check the value 1.25 and 1.26 by using calculator. Remember, change your calculator into radian mode. So over here, you will get this as 0.014. That is positive. So it's negative 0.0021. Negative. Okay. So you can see that there's a change of the signs. So because of there is changes of sign between 1.5 and 1.6, 1.25 and 1.26. Therefore, phi is between 1.26 and 1.25. That will be the answer for the C. Now D. Show that the area of the smaller region enclosed by the C1 and C2 is equal to this. Okay, we want to show that the area smaller region enclosed by C1 and C2. And after that, deduce in terms of A and phi the area of a larger region enclosed by C1 and C2. So over here, if you refer to the diagram, okay, if you refer to the diagram, this is the smaller area. Oops. This is the area enclosed by the C1 and C2. This one is a smaller one. This one is a larger one. So we are looking for the small, we need to show the smaller area look like this. After that, we want to find the larger area. Okay. So now the smaller area, I call it A1. Formula, it will be half integrate r squared d theta plus half integrate r squared d theta. So over here, the smaller area, let me just explain over here. This is the circle. This is the circle. This is the spiral. And this is the intersection. So this A1 is, we will be using this area plus this area together, these two areas together. So this area will be here. This area will be here. So for the spiral is theta equal to 0 until theta equal to 5. So this one is a 0 until 5. And then we will be using this equal to the A theta over here. So this one for the spiral. Then for the circle will be here. The circle, it will be the theta equal to 5 until theta over here is 3 pi over 4. Okay, you can see that this is 3 pi over 4. So just integrate until 3 pi over 4. So this one will be 5 until 3 pi over 4. Okay, so this is what we need to set up first at the very beginning. Now, just replace this with the value. Become a square theta square. This one, it will be 5 to 3 pi over 4. It will become a square cos theta plus I theta square. So over here, I factorize the a square over 2 out. Theta cube over 3, 0 to 5. Factorize the a square over 2 out. Expand them. It will become cos square plus sine square plus the 2 cos theta sine theta d theta. Okay. So this one will be 1 over 6 a square 5 cube. This one will be a square over 2. Haven't integrate yet. We need to simplify them using the trigonometric identity. So this one is a 1 over 6 a square 5 cube. Integrate theta minus a half cos 2 theta. Put the 5 and 3 pi over 4 inside. Then you will get this one as a 1 over 6 a square 5 cube plus the a square over 2. 3 pi over 4 minus a 1 over 2 cos. Okay. 3 pi over 4 minus a half cos 3 pi over 2 minus a 5 plus the half cos 2 pi. What do they want you to show? They want you to show that the area looks like this. Factorize the half a square out. Then inside here will be 5 cube plus the 3 pi over 4. This is a 0 minus a 5. Then plus the half cos 2 pi. Okay, so the answer is correct already, but just that the arrangement is different. So maybe we can arrange them same as the questions over here. We put 3 pi over 4 here, and then I put 5 cube over here, so that the arrangement same as the question given, shown. That is the That is the answer for the first part. Now the second part is that we want to find the area of the larger region. So the area of larger region is equal to the area of circle minus the A1. What is the area of circle? Area of circle, the radius is 1 over 2, 1 over 2a. So it will be pi a square over 2 minus the half a square 3 pi over 4 plus 5 cubed minus a 5 plus half cos 2 phi. Also factorize the half a square out, and you will get this one as a pi over 4 minus the 5 cubed plus 5 minus a half cos 2 phi. Done. That will be the answer for the question number 7B. And this will be the last question for this paper. So I'll stop the video here. I'll see you next time. Bye-bye.